Okay, so simplifying radicals, you have two different thoughts, and there are different times that I will use different ones. Um, one is using the prime factorization method, one is using the perfect square method. To do the perfect square method, we need to have perfect squares in our head. So let's maybe flip to the back if you have room. Let's make a list of all the perfect squares. So perfect squares. Can somebody give me a couple? Or what would the first perfect square be? What did we say? 1. Okay, give me some more. 4. What else? 9. 16. 25. 36. 49. 64. 81. 100, 121, 144, 169, 196, 225, and that's about where I am. Now, why is 36 considered a perfect square? Because 6 times 6 is 36. It's 6 squared. It's a perfect square. You think about a square, it's a square because the side lengths are the same. Now, what do you think about our cubes, our perfect cubes? What would be our first perfect cube? 1, because 1 times 1 times 1 is 1. What's the next one? 8. That's 2 cubed. The next one? 27. Next? 64. Next. 125. Next. 216. And I believe we end up with 343. 749 times 7, 63, 6 and 28. Yeah. So these are perfect cubes. They're cubes because 2 cubed is 8. 3 cubed is 27. Okay, so this is something that we kind of have to keep in our heads. So let's flip back and look at the way that we do this. If I have a really large number, or I'm multiplying radicals, or if you struggle with prime factorization, you struggle with knowing your factors, prime factorization would be your method. So let's look at what we did here. We're going to kind of write over where it didn't work out real well. So the problem was the square root of 18x squared y cubed. So we broke down the 18. We got 2 and 9. 9 breaks into 3 and 3. So we rewrote the radical as the square root of 2 times 3 times 3 x, x, y, y, y. Now, we are doing the square root, so we need pairs. So everybody, I'm sure, has this box or this tub of socks. Everybody have that tub of socks? It's the place where all the socks go that don't have matches. And when you get really desperate and there are no socks in your drawer, then you go digging through that basket until you find what? A pair. 2 socks that are the same. Now, some of us settle for almost the same. But we put those 2 socks together, we ball them up, and we throw them out. That is what we are doing here. In this basket, I have a 2 sock, a 3 sock, a 3 sock, an X, a Y, Y, and a Y. Now, we're going to pair them up. So I have a pair of 3s, so I'm going to ball them up. Square root of 3 times 3 is 3. The square root of x times x is x. Square root of y times y is y. Now, 2 and y don't have a mate. So what do you do with those socks that don't have mates? You leave them in the basket. So that's what we did here. We have 3x, y times the square root of 2y. Now, can you have a radical come from under, or can you have a number come out of a radical and be negative? No. So in Algebra 2, we force this need of putting absolute value marks around those variables to force them to be positive. So we would have 3 absolute value of x, absolute value of y, times the square root of 2y. Now, the perfect square method is you looking at that list, 1, 4, 9, 16. What of 18, which of those are a factor of 18? 9. So 2 times 9, x squared, y squared, y. Why did I split out the y squared and the y? Because do I have enough for pairs? No, I've got one pair and I've got a leftover. Now, if you had 3 white socks that are exactly the same, are you going to wear all 3 of those at the same time? Probably not. You're going to pair up the pair and you're going to throw the lonely socks back in. So that's what we did here. So then you take the square root of 9 and you get 3. The square root of x squared, you get x. Square root of y squared, you get y. Why did I throw the 2 and the y together? That's the leftovers. Okay? So, at the bottom, let's do one more example and then we're going to get boards out. This is the one that I would like you to work now. The square root of 24 a squared b. Square root of 24 a squared b. So if you were to use the prime factorization method, you'd break 24 down, you'd probably say 2 and 12. You break it all down, you get 2, 3, 2, 2, AAB. Okay? Then we would circle our pairs. I have a pair of 2's. Square root of 2 times 2 is 2. Square root of a times a is a. Leftover would be 6b. Who needs absolute value marks? A. If you were doing it the perfect square method, and I want you guys to go towards that method, simply because 1, it's faster, and 2, you're going to have to be able to do this stuff in pre-calc. So 18, so you'd look at your list. Which of these factors are a factor of 18? Or no, 24. We're on 24. Which of these factors are a factor of 24? 4. 4 times what is 24? 6. And then I've got my a squared and my b, the square root of 4, square root of 6, square root of a squared, square root of b. Square root of 4 is what? 2. What's the square root of a squared? A. And what's left over? 6b. So I get the same thing. It doesn't matter which way you go. All right.